1. Astronomers witness the dawn of a new solar system around baby star HOPS-315. 2. Astronomers witness the birth of a new solar system HOPS-315 planet formation discovery. 1. Astronomers witness the dawn of a new solar system around baby star HOPS-315. For the very first time, astronomers have made a groundbreaking discovery. They have pinpointed the exact moment when planets began to form around a star that is not our Sun, utilizing the advanced capabilities of the ALMA telescope, a project in which the European Southern Observatory (ESO) plays a significant role alongside the James Webb Space Telescope. Researchers have observed the initial formation of planet-building materials, specifically hot minerals that are just starting to solidify. This remarkable finding represents the earliest identification of a planetary system in its formative stages, providing a fascinating glimpse into the early history of our own solar system. This is the first time we have successfully identified the very beginning of planet formation around a star other than our Sun, states Melissa McClure, a professor at Leiden University in the Netherlands and the lead author of the study published today in the journal Nature. Co-author Merel van 't Hoff, a professor at Purdue University in the USA, likens their discovery to a snapshot of a baby solar system, explaining that we are observing a system that resembles what our solar system looked like during its initial formation phase. The newly forming planetary system is located around HOPS-315, a proto or baby star situated approximately 1,300 light-years away from Earth, serving as an analog to the young Sun. Around such nascent stars, astronomers frequently observe disks of gas and dust, referred to as protoplanetary disks, which are the very cradles of new planets. Although astronomers have previously detected young disks containing massive, Jupiter-like planets, McClure emphasizes that we have always understood that the first solid components of planets, known as planetesimals, must form much earlier in the timeline. In our own solar system, the earliest solid materials that condensed near the current location of Earth around the Sun are found within ancient meteorites. Astronomers utilize these primordial rocks to date the onset of our solar system's formation. These meteorites are rich in crystalline minerals that include silicon monoxide (CO), which can condense at the extremely high temperatures found in young planetary disks. Over time, these newly formed solids coalesce, laying the groundwork for planet formation as they increase in size and mass. The first planetesimals, measuring kilometers in size and eventually evolving into planets like Earth or the core of Jupiter, formed shortly after the condensation of these crystalline minerals. With this new discovery, astronomers have gathered evidence of these hot minerals beginning to condense in the disk surrounding HOPS-315. Their findings indicate that CO exists around the baby star in both gaseous and crystalline forms, suggesting that it is just starting to solidify. This process has never been observed before in a protoplanetary disk, or anywhere outside our solar system, remarks co-author Edwin Bergen, a professor at the University of Michigan, USA. The identification of these minerals was achieved using the James Webb Space Telescope, a collaborative effort among the US, European, and Canadian space agencies. To accurately locate the source of the signals, the research team employed ALMA, the Atacama Large Millimeter/Submillimeter Array, which is operated by ESO in partnership with international collaborators in Chile's Atacama Desert. Through their observations, the team determined that the chemical signals originated from a small region of the disk around the star, comparable to the orbit of the asteroid belt in our solar system. We are truly observing these minerals in the same location within this extrasolar system, as we find them in asteroids in our own solar system, explains co-author Logan Francis, a postdoctoral researcher at Leiden University. This makes the disk of HOPS-315 an exceptional model for investigating our own cosmic history. As Van 't Hoff notes, this system is one of the best we have to explore some of the processes that occurred in our solar system. It also presents astronomers with a fresh opportunity to study the early stages of planet formation, acting as a stand-in for the formation of newborn solar systems throughout the galaxy. Elizabeth Humphreys, an astronomer at ESO and the European ALMA program manager, who was not involved in the study, expresses her admiration for the research. I was genuinely impressed by this study, which unveils a very early phase of planet formation. It suggests that HOPS-315 can be instrumental in understanding how our own solar system came into being. This finding underscores the combined power of JWST and ALMA in exploring protoplanetary disks. For further details, this research is documented in the paper titled Refractory Solid Condensation Detected in an Embedded Protoplanetary Disk, doi 10.1038/S41586-025-09163Z, set to appear in Nature. The research team includes M. K. McClure Leiden Observatory, Leiden University, the Netherlands, M. Van T. Hoff, Department of Astronomy, University of Michigan, USA, and Purdue University, Department of Physics and Astronomy, Indiana, USA, L. Francis, Leiden, Edwin Bergen, Michigan, WRM, Rocha Leiden, J. A. Sturm Leiden, D. Harsono, Institute of Astronomy, National Tsinghua University, Taiwan, E. F. Vandishoek, Leiden, J. H. Black, Chalmers University of Technology, Sweden, J. A. Noble, CNRS, Aix-Marseille University, France, D. Qasim Southwest Research Institute, Texas, USA, and E. Dartois, CNRS University Paris-Saclay, France. The Atacama Large Millimeter/Submillimeter Array ALMA is an international astronomical facility, a collaboration between ESO, the U.S. National Science Foundation, NSF, and the National Institutes of Natural Sciences, NINS, of Japan, in partnership with the Republic of Chile. ALMA is funded by ESO on behalf of its member states, by NSF in collaboration with the National Research Council of Canada, NRC, and by NINS in cooperation with the Academia Sinica in Taiwan and the Korea Astronomy and Space Science Institute, KASI. The construction and operations of ALMA are led by ESO on behalf of its member states, by the National Radio Astronomy Observatory, NRAO, for North America, and by the National Astronomical Observatory of Japan, NAOJ, for East Asia. The Joint ALMA Observatory, JAO, oversees the unified leadership and management of ALMA's construction, commissioning, and operation. The European Southern Observatory, ESO, empowers scientists globally to uncover the mysteries of the universe for the benefit of all. We design, construct, and operate top-tier observatories on Earth, which astronomers utilize to address intriguing questions and share the wonders of astronomy, while fostering international collaboration in the field. Established as an intergovernmental organization in 1962, ESO is currently supported by 16 member states, along with the host nation of Chile and Australia as a strategic partner. ESO's headquarters and its visitor center, the ESO Supernova, are located near Munich, Germany, while our telescopes are situated in the Atacama Desert of Chile, a remarkable location with exceptional conditions for sky observation. ESO operates 3 observing sites: La Silla, Paranal, and Schujnanter. At Paranal, ESO manages the Very Large Telescope and its interferometer, as well as survey telescopes like Vista. Additionally, at Paranal, ESO will host and operate the Cherenkov Telescope Array South, the largest and most sensitive gamma-ray observatory in the world. In collaboration with international partners, ESO operates ALMA at Schujnanter, a facility that observes the universe in the millimeter and submillimeter wavelengths. At Cerro Armazones near Paranal, we are constructing the world's largest eye on the sky, ESO's extremely large telescope. From our offices in Santiago, Chile, we support our operations in the country and engage with Chilean partners in society. 2. Astronomers witnessed the birth of a new solar system HOPS-315 planet formation discovery. Imagine being present at the very beginning of our own solar system's formation. For the first time, astronomers have witnessed the birth of a planetary system that could one day look eerily similar to our own. This groundbreaking discovery offers scientists a unique window into understanding how our home planetary system came to be around 4.6 billion years ago. The team's findings revolve around an infant star named HOPS-315, located about 1,300 light-years away, where specks of material that will eventually form planets are starting to coalesce. The breakthrough was made possible by data from the Atacama Large Millimeter/Submillimeter Array, ALMA, and observations from the James Webb Space Telescope, JWST. These powerful tools allowed scientists to pinpoint the earliest stages of planet formation around a star other than our Sun. As team leader and Leiden University researcher Melissa McClure noted, "For the first time, we have identified the earliest moment when planet formation is initiated around a star, other than our Sun. The study, published in the journal Nature, focuses on understanding protostars and protoplanetary disks. When stars form, they collapse from cool and overdense patches of interstellar gas and dust, eventually becoming surrounded by a swirling disk known as a protoplanetary disk. This disk is crucial for the formation of new planets. Astronomers have often observed infant stars with massive protoplanetary disks containing young Jupiter-sized worlds. However, to study the origins of these planets, scientists needed to observe these disks in their earliest stages. The team points out that the first solid parts of planets, or planetesimals, must form further back in time at these earlier stages. One key clue to understanding these early stages can be found in meteorites on Earth. These space rocks contain a fossil record of our solar system, including crystalline minerals that formed 4.6 billion years ago. These minerals, such as silicon monoxide, were the first solid matter in our solar system and eventually formed mile-wide planetesimals, the seeds of Earth and the cores of gas giants like Jupiter. The team detected silicon monoxide in both gaseous and crystalline forms around HOPS-315, suggesting that the condensation of minerals has just begun. This process has never been observed before in a protoplanetary disk outside our solar system, making HOPS-315 an excellent proxy for studying our cosmic history. But here's where it gets controversial. While this discovery offers a unique window into planet formation, it also raises questions about why our solar system might have formed differently or similarly to others. Could the conditions that led to the birth of our solar system be replicated elsewhere, or are they unique? And this is the part most people miss. The discovery of such a system opens up new avenues for research into the possibility of life beyond Earth. If planetary systems similar to ours can form elsewhere, what are the chances of finding life elsewhere in the universe? The general public might wonder, do these findings mean that there could be other Earth-like planets out there? Should we be searching for them using similar methods? What do you think about the implications of this discovery? Share your thoughts in the comments below.